population. That's one sample, not two samples. Okay. In this chapter, we look at hypothesis regarding a simple population parameter. And we are only going to start with proportion, proportion P. Just a quick reminder, big P is population, population proportion. P hat is sample proportion. So this is a statistic. This is a statistic. P hat is a statistic or the point estimate, and P is a parameter. We use P hat, the point estimate, to estimate the parameter P, the big P, capital P. So P hat is the estimator. Okay, so we are going to read some examples and quickly start, look at, and then we will do many examples. It's going to be easier when we do some examples. Okay, so somebody has to make a claim. So this is a claim somebody made some time ago. In 2028, 62% of American adults, regularly volunteered their time for charity work. A researcher believes that this percentage is different. I want you to understand that the keyword matters in hypothesis testing. So a researcher claimed that the percentage is 62, and there are some keywords we must know. Is, when we're here, is the same thing as equal sign. So the keyword is equal sign. And whenever the keyword is equal sign, the alternative, which I call the alternative hypothesis, is different. So this is different. And that means that the hypothesis is stated for the status quo. The way it is, that's how it is now. I'm going to do an example. So you will start. There are 6 steps. I'll make it 5 steps, so that you will remember. So what I'm going to do now is start. And actually, I will, okay, let's start writing the steps. It'll be good for us to write the steps that way. So I'm going to open another, let me get another. Okay. And then, so now I want to write the 6 steps in hypothesis testing here. So I'm going to write the examples here. Examples, hypothesis testing intro. All right, so I am going to save it right here on the desktop. Okay. All right, 6 steps in hypothesis testing. So I'm going to write step 1, 6 steps in hypothesis testing. Hypothesis testing. All right, step 1, identify the claim. Identify the claim. What is the person claiming? What is he saying? Identify the claim. In other words, read the question and find the keyword. And this claim can be can say is, which is two-tailed. So this is the way we identify the claim. So the person will just make a claim, and we shall call it. It depends on the keyword. So HO, the null hypothesis, the claim has to be 2, H, or the null hypothesis. Today we're talking about P. So the parameter is P. And if the keyword is means equal sign, so the null hypothesis is equal sign. And now this person was saying 64%, so I'll put it in decimal. So the claim is that the percentage is 64. Percentage of volunteers is 64. That's what the claim is. Well, if somebody wants to disobey, does not agree, then there's an alternative hypothesis. And that alternative hypothesis will say the opposite of equal sign, not equal to. And I want you to know that not equal to can be greater than or less than. So the next thing you want to do after you identify the claim, this is still step one. You draw a normal curve. Draw a normal curve. You shade the tails, because actually not equal to means two tails. So this is two tails. Two tails, because it's not equal to. So it means it can be greater on the right or less than. Okay, well, suppose the claim says, I am going to pull this up. Suppose the claim says, let me see. Or suppose the claim says HO mu is greater than, if suppose it said that, 64, then the alternative, by the way, I want to make sure I take this off. I want to emphasize the part that the null hypothesis always have equal sign. So the alternative hypothesis has to be greater than if the person claimed equal to. So I just corrected that. So we call this one tail right, one-tailed right. So we draw a normal curve. And so the critical region is going to be only on one side because it's a one-tailed right test. Or suppose the claim is less than 64. So let's call this one B, and we call this one C. Suppose somebody made the claim and said the percentage of those who volunteer is less than 64. You write a claim. Either way, you must write a claim. The sum, the parameter is equal to 64 because the null hypothesis must be equal signs. That's what we call equal sign. And the alternative hypothesis, this time the keyword is less than. So the keyword is less than 64. You still draw a normal curve. You draw a normal curve for this. So I'm going to draw a normal curve with a tail at the left-hand side. Left tail. Okay. So there are three ways you can see the claim depending on the keyword. Depending on the keyword, the claim can be greater than, less than, not equal to. Okay. All right, so now we just started with step one. So we have only written step one. In any hypothesis testing, you are only testing one of them. It could be you are testing A, or you are testing B, or you are testing C. It cannot be all of them. It has to be one of them. When a hypothesis test is two-tailed, you can actually use, or the question can tell you to use a two-tailed test, or tell you to use confidence interval. So in hypothesis testing, you can do two-tailed tests. You can also do confidence interval. The question can tell you that. So very soon we shall do some examples. All right. Okay, so step 2. So I'm writing these steps because they are very important. You must know the steps. All right, so we are done with step 1. Step 2 of hypothesis testing, identify the, you have identified the claim. The next thing is, what is the alpha? So identify alpha. Identify alpha. And what does alpha mean? Area in the tails. Whenever it is two-tailed, alpha, it has to be alpha over 2, two-tailed. Okay? If two-tailed, then you have alpha over 2. If it is two-tailed alpha, you divide alpha by 2. All right, so you can be given that you're doing the tests for alpha of 5%. 5% is 0.05. Therefore, alpha over 2 is divide 5% by 2, 0.025. And then, if it is if you're told to find a critical value for 5% two-tailed, we did it last week, but I want to just make sure I remind you that you can find the critical value. So inverse norm 0.025. For a reminder, let's do that again. I told you can find it with your chart, but I hope you don't waste all your time because you have 20 questions in that test. You have 20 questions in the test on the 22nd. By the way, our test is going to be on the 22nd. And you have 20 questions, and you want to finish the questions. Each question is 5 points. So, and you are allowed to use your calculator. So go ahead and use your calculator. Okay, so now we have, you are looking for inverse norm. So remember where to get inverse norm. Second distribution, you go to inverse norm, which is number 3. If it's a small sample, you go to inverse T. An area to the left is 2.025 or 2.5%. And the mean is 0, standard deviation is 1, so you have to calculate that area. Therefore, area to the left, the z value corresponding to area to the left is negative 1.96. The z value corresponding to area to the left is negative 1.96. So negative 1.96. Remember that normal curve is symmetrical. Therefore, the z value corresponding to this is the opposite, 1.96. So we have done step 2 of hypothesis testing. The next step is step 3. Everybody should know the 5 steps. You must know the 5 steps. Step 3, now that you have alpha, you use alpha to calculate, we already calculated the critical value. So we have calculated the critical value. Calculate the critical value, CV. That's what we just did here. Calculate the critical value from your alpha. And when you calculate these critical values, they are the boundary line from rejection and acceptance. So the acceptance region is the open space here. The rejection region are the shaded region. Okay, calculate the critical value. Number 4, calculate the test statistic. Calculate the test statistic. So the test statistics can be a T or a P or a Z. In this question here, we are doing a P. So the test statistics must be P test statistic. And what is the formula? You must know the formula. And you must know the condition. So what is the formula and what is the condition? First of all, you know your condition has to be met. We talked about it last week. Let's talk about it again. The variance must be greater than or equal to 10. The variance must be greater than or equal to 10. Condition number 1. Condition number 2, the sample size must be less than 5% of population. Population is capital N, sample size is small n. If the two conditions are met, then you are ready to do hypothesis testing. So calculate the test statistic. All right, so if I know that I'm doing hypothesis testing for P, then I must write the formula for P. Okay, so the next thing is calculate. I'll write this formula right very soon. So the next one is, okay. I wonder why you're not moving anymore. What's wrong with you? Okay, so we are now going to calculate number 5. Number 5 is make a conclusion with your, make a conclusion. No, I'm going to clear. So that is not, if it's not working. So the next one is write the equation and conclude. So now I need to write this equation, which is number 4, the test statistics. And we are doing a proportion hypothesis testing today. So I am going to write a test statistic. This is Z, P hat, that is what I'm trying to, and is P hat minus P all over the standard error of, this is assuming that everything, the conditions are met though. So P hat, Q hat, divided by sample size, where the conditions are met, where N is less than 5% of population, and NPQ is greater than or equal to 10. Remember that this P and Q are, they are sample because you are actually looking for the population P. You don't know what it is. You don't know what it is, so it can't, so and remember that this P here is the population, the one given to you, the one you are contesting, the one you're contesting. So now number 5 is make a conclusion from your, there are 2 ways of making a conclusion. You can check if alpha, you can use the p-value. Using the p-value, if alpha is greater, if p-value is greater than alpha, you accept the null hypothesis. If p-value is less than alpha, you reject the null hypothesis. Then you conclude. When you reject the null hypothesis, you say, I do not have enough evidence to reject the status quo, because the status quo is always the null hypothesis. If I do not have enough evidence to reject the status quo, but if you rejected the null hypothesis, in other words, the p-value is less than alpha, then you said, I do not have enough evidence to accept the status quo. Okay, you now say that whatever somebody claimed is not binding, it's not true. Okay, so conclusion. Conclude in non-technical terms. Remember that you don't go ahead, don't just go there and tell them about alpha and null hypothesis. They don't know what you're saying. You are the one hired to do the job as a statistician. So when you finish, you tell them that whatever we had before is still working. There is no need for a change. You don't have any need for a change right now. Okay. So now that we have stated, I have written all the 5 steps. Let's go ahead and do some examples. let's go ahead and do some examples. So the first thing is the language of statistics. That is what I just stated. When you read the book and you watch some other videos in the book, you will see more. But this is the introduction that you need to know. Everybody needs to know the 5 steps. The first step is identify the claim, the null hypothesis, and alternative hypothesis. Number 2 is identify alpha. Number 3 is calculate the critical values. Number 4 is calculate the test statistic. And number 5 is use the test statistic to make the decision, or use the p-value to make the decision. If it's a two-tailed test, you can also use confidence interval to make the decision. Okay. All right. So I already posted the practice test. It's in. I already assigned practice test in. I would like you to read the notes. I would like you to read the notes. Reading the notes will help you a lot. So these are examples of what I just said already. I already talked about this. These are the steps in hypothesis. That's right-tailed, left-tailed. But I think the best thing for us is start doing examples. Another thing you must know is what we call type 1 error and type 2 error. There are 4 outcomes from hypothesis testing. All right, I'm going to draw a picture. I think when I picture, that picture is analyze all and for yeah. All right. Okay. Suppose that HO is true. HO is false, and you accept HO. Accept HO. Good decision. Correct decision. I wrote through here, and I wrote false. You come alpha error. If HO is true and you rejected it, if you rejected HO when it is true, you committed an error because it is true, but you rejected it. So this is an error called type 2 error or beta error. Reject HO when it is true, type 2 error. Accept HO when it is false, type 1 error. If you reject HO when it is false, then decision. So you see, this first table, this table is in your book. You can draw the table, then you can write the test. I just want to let you know it's in the test already. It's always in the test. One will answer the question. The kind of decision you make in hypothesis testing matters a lot. Because when you finish this class, you can get into your master's degree and do your master's thesis. In your thesis, you will be asked about hypothesis testing. You'll be doing a test. with hypothesis test. Go and problems now. So the note for today, clean this side, and so we can go and get a question. And so this time there are size for proportion. The sample size for proportion is equal to p hat q hat parenthesis squared. Margin of error is in the denominator, and then the critical value, z critical value 2 tells, z alpha over 2. Well, it is assumed that the conditions are met. NPQ is greater than 10, and the sample is from a normal is less than 5% of the normal distribution of population. Okay. Okay, so now we're going to do the calculation. We are given everything. So the P rewrite it here. So n is equal to 37.37. That's P times divide 6% by 2. So inverse norm 0.03. So here I'll find inverse norm 0.03. That's the critical value. .03. Okay, there I can now calculate. So I bring out my calculator. Remember that we have to square this. So this calculation of sample size for proportion. You can be told to find the given to you, and you have a formula sheet though. Okay, so you want to calculate the critical value first. So second distribution, number 3, area to the left is 0.03, and then other things are good. And when I hit enter, I have and then I know that this has to be square. Divided by 0.03. And I have to square my answer squared. My answer with N, P, and Q. So multiply by P 0.37. And then I multiply again by 1 minus 0.37. 1 minus 0.37. And I will now get my final answer. My final answer, let's see what happened there. Okay, 2. Therefore, the estimated sample size is 917. You have to round up. I know someone is going to say, why did you round up? You have to round up. In calculation of sample size, even if the decimal point is 0.00005, You still have to round up. That is the rule, because the answer must be discrete. It cannot be negative. The answer for calculation of sample size must be discrete, and it cannot be negative, of course. Okay, well, that question is question number 8. Let's see the question number. What's the question number? Oh, actually number 4. Okay, well, let's see. Okay, so this, see, your answer will be 917, not 916. Check your answer, see if one question on hypothesis testing for proportion. Okay, so one question on hypothesis testing for proportion. For goodness sake, I've been using this. Okay, so we're going to get a question on hypothesis testing for proportion. I can actually get one from here. Okay. What can you conclude? Test this. Okay. Okay. So let's look at question number 3. Question number 3 in this, I'm going to put this in Blackboard also. So the question here, how do I know that this is a proportion hypothesis testing? First of all, the mean is given to me in percent, and they give me a sample size. So I'm using this sample to estimate whatever I have. This is X. Okay, so I have to start first. What is the point estimate? P hat. The point estimate is P hat, and that is X over N. What is X? X is 450. 103. The point estimate. I need. Let me write alpha the way it should be written. One tail right or one tail left. A communications industry spokesman claims that over 40% of Americans either own a cellular phone or have a family member who does have a cellular phone. Wow, that is an old question. People have more right now. Okay. 456 hertz. All right. A family member has a cell phone. Test the spokesman's claim at. Okay, I want you to know that this is over. The keyword is over. Therefore, we are doing a right tail test. So we start. I'm going to identify the claim. Step 1, I'm going to identify. Step 1 is identify the claim. So null hypothesis, the P is equal to 40%, 0.4. Alternative hypothesis for one tail right, P is greater than, because it's over, greater than. So this is only one tail test. All right, so number 2, I'm actually as 5%, 0.5. That's step 2. Step 3 is find the critical value. The critical value is inverse norm, 0.05. I will not divide by 2 because it's a one tail right. So I will go to, and I will not divide by 2. The critical value for a one tail right test. That's what I'm looking for. So you have to be careful. You need to know what you're looking for. Okay, So inverse num, then 0.05. I'm not dividing that by 2 because it's a one-tail right. And I'll remember to change my answer to positive. All right, so I have negative 1.64. So I'll change it to positive. Why? Because I'm doing a right tail z equal to 1.64. 1.64. Okay, and now I am going to calculate. You'll be asked to calculate all this though. If I'm told to calculate the test statistic, I can just put it in the formula. The formula we talked about before is Z p hat is equal to p hat minus population proportion over standard error of proportion p hat times q hat over sample size, provided the conditions are met. Okay, that's what I'm supposed to calculate. I don't really have to do that. So I will go to my calculator and do the hypothesis testing in there. So let me show you how to do it in 5 minutes, in less than 5 minutes, using your calculator. Because I'm expected to show you that too. I am expected to show you how to use your calculator and how to do it without calculator. So where do we go? In hypothesis testing and confidence interval, you go to STAT. Test. What am I testing? I am testing proportion hypothesis testing. So I will arrow down test. Why? It is one prop Z test because the conditions are met and both conditions are met. Sample size is less than 5%. I didn't test it, but I know that 1,000 is less than 5% of the population of America. I know that. And then NPQ must be greater than 10. When you come to test, you select one prop Z test. So I'm going to select. Now to us, it is many people will. Let's check that out. Okay, and I'm going to arrow down. The sample size is 1,036. And then I'm doing a right tail test. I have to tell my calculator. So the population proportion is okay. So let's see what dimension is. Saying dimension quit. Okay, let me go back to see what is saying. One prop Z test. Okay, 0.4. So what is not right now? What is not right? Let's see. Okay, let me see if I can calculate what's to know what the problem. What is the problem? So why did it not draw? Okay. Anyway, so if I look at the what I'm given for approximately the p-value is 0.004. P-value is too small. P-value is less than alpha because alpha is 5%. So since p-value is less than alpha, we are going to reject the null hypothesis. The status quo is not true, it's not working. So now it's time to make a decision. Because p-value is greater than alpha, I'll reject the null. Also, the test statistics falls into the rejection region on the right. The test statistics falls into the rejection region. So I can reject or accept with the test statistics or with p-value. Remember, if you're using p-value, you can't be told to use p-value. If you're using p-value, if p-value is greater than alpha, then you accept the null. If p-value is less than alpha, you reject the null. And the p-value conclusion and the test statistics must give you the same answer. Okay, so we rejected the null, and we can now say that the alternative is working. The hypothesis, the status quo is no longer working. Therefore, it is actually true that more than 40%. It is actually true that when you go to families now, more than 40% of them have a cell phone. I know that you can actually predict this test before you start. Okay, so example, but we will do more examples next class. But now you can answer questions in your section 10.1 homework for tonight. Section second, practice test is already posted. Practice test is already posted. Okay. All right. Okay, so we're going to stop here and then we continue next class. If you have any question,